and it might not mean anything. So we might have calculated this, and I mean, quite honestly, I would have looked at this. I looked at the scatter plot at first and thought, why am I even doing this? Okay? So the point is, you can have a scatter plot that doesn't look like anything, and people still, because they're trying to push the issue, they really believe they want it to work, they start doing all these calculations to make it look good. It looks like I did a whole lot. It looks convincing. Well, let's do a test now to see if it really is. So, this is just starting of a test. So at first glance, it appears that there is a positive association between milk consumption and mucus secretion, since the sample slope is 0.0567, which is greater than 0. The slope we got from doing our regression is positive. That's why we say there's a positive relationship. The more milk you drink, the more mucus you produce. Are you counting the number of people falling asleep, Trevor?
People watching.
Because I am too.
I'm not asleep, I'm listening.
Okay. No, it's okay. We're on the same wavelength here. I'm like napping, dozing, needs a little something thrown at him. Okay, sorry. I won't throw things. Coffee? I should get a little coffee pot in here and...
Oh my God.
Get a Keurig.
I could get a Keurig, yes, I could.
Windows in here, I think you're probably...
You know what? I have asked for windows for
I
years.
think there needs to be...
You can't. It's not possible. You can't do it.
Well, no, but I mean, like, the fact that...
So, it is possible that there's no association between the variables, though. Even though we got a positive slope, there's still a chance that there's no association between the variables, and we got a slope this high due to randomization variability. Why do we say randomization variability? Because it's an experiment. So, does this sound very similar to other tests we've done?
Yes.
Yes, it does, okay? So, we are testing between for an association between two numerical variables. We're going to consider the slope of the least squares regression line, okay? What we're doing a test for is to see if our slope is a good slope. Why? Because the slope of a regression line is typically the key part of it. It tells you how slanted it is. We could do a test for the y-intercept. We could do a test for the correlation. In fact, there's tests out there for that, but we're not required to cover those in AP Stats. If you take more statistics in college, you just need to know there's lots more tests you can do than what we're learning. So, but we are going to do a test for the slope, and slope we're going to refer to as B. So we're going to do a test for the slope. So our question is, how likely is it to get a slope this high just due to randomization variability when there really is no association between milk and mucus? And we are not going to do a simulation. We're going to skip that part. We're just going to go straight to the test. So that's really what we want to do. So what you need to know about the null hypothesis and the alternative hypothesis in a test for slope, the null hypothesis will be that there is no association between our two variables, milk and mucus. And the alternative is we don't just say no association, we have a way of saying there's a positive association, a negative association. So what are we going to choose? Positive, because our slope was positive. So the alternative is that there is a positive relationship. Now, in terms of variables, the way we'll write this, slope is going to be our variable that we're doing our test to get on. So slope, I know it's B, but we refer to it as beta. Okay, beta is the slope, that's the true slope. That's the true slope. And little b is the sample slope. Compare this to things like x bar is the sample mean and mu is the population mean. So when you write hypotheses, you always use the population value. So if there's no association between milk and mucus, that means the slope is equal to what value? 0. And since we're saying there's a positive relationship, we're then saying beta is greater than 0. So these you can use instead of the words. Jacob.
Does this beta have anything to do with the power of the test beta?
No.
Okay.
It's a different beta. It's just, yep, it's a different beta. So now we've got just a little blurb down here on the different notations that you can do. In most studies, we use data to calculate regression lines. That's why we didn't do the simulation here. The data we're using comes from a random sample or randomized experiment. So, thus, the values we find are really just estimates of true values. So, here's the variables that we use. This is what we use to write our regression line. Y hat, which is our sample y's, and A plus BX. The AP Stats test uses B0 and B1. So that's, you're going to have to make that connection that B0 is the same as A and B1 is the slope. The true linear regression line would be alpha plus beta x, or beta sub 0 plus beta sub 1x. Okay, the sample correlation coefficient is R, and the true correlation coefficient is this. It looks like a P. It's the Greek letter rho. And you aren't going to see that we aren't doing tests on this, so you don't really need to worry about that. And then the estimated or sample standard deviation is S with a little e, and the true is sigma with a little e. And this is just notation, how we write things. Okay, so now we have the full test. This is pretty much something we started similar to this on the previous page. So at first glance, it appears that the true slope of the least squares regression line using x equals glasses of milk and y equals ounces of mucus is greater than 0, since the sample slope is 0.0567. But it is possible that there is no association between the variables and we got a slope this high due to randomization variability. If we hadn't done an experiment, if we just took a sample, it would be sampling variability. To decide, I will conduct a linear regression T test for beta. That's the name of the new test. Linear regression T test for beta, for the slope. And you pick an alpha level. So all we have that's different is we have a different, all we're doing is saying that we're talking about the slope. So the first thing we're going to have to do is do a stat calc 8. We're going to have to calculate the linear regression and look at the slope and say, is it positive or negative? And then you just make a statement. It appears that the slope is positive or negative. And then you describe what the x and the y variables are. And then say that, well, it's possible there's no association. And we got this slope because of sampling or randomization variability. And then we're going to do a linear regression T test. This test is going to tell us how good our slope is. What's the probability that I got this slope value, assuming there's no relationship? And if the p-value is small, then we can say, hey, there probably is a linear association. Why does it seem like when I'm talking or someone's talking and the bell goes, it's like really long? Sorry. Okay, so the null hypothesis is that there is no association between milk consumption and mucus secretion, and the alternative is there is a positive association. So, some questions will ask if there is a useful linear relationship between the two variables. It's simply asking if there is a linear association. In other words, it could be a positive, it could be negative. So then you could say beta is just not equal to 0. So it could be, they just want to know, is there a useful linear relationship? So the conditions, we're skipping the conditions for now. That takes a whole nother day to just explain the conditions. The conditions aren't hard to check, by the way, but they deserve a little bit more of an explanation for now. So we get to skip any conditions on this homework for now. And our test statistic is the observed slope. So T is equal to the observed slope, the one you get from calculation, minus the true slope, which we're always assuming is actually 0. We're assuming the true slope, the hypothesized slope. This is also the hypothesized slope. Hypothesized slope is 0. The observed slope minus the true slope divided by the standard deviation of the slope standard deviation of the slope with n minus 2 degrees of freedom. And n is the number of observations. So, little notes here, the S sub b is the standard error of the slope. It describes how variable the sample slope is for the given sample size, etc. This is the variability we saw in our dot plot earlier. This is different than S sub e, the standard error of the residuals. They're very related. So the standard error of the slope is basically the standard error of the residuals divided by the standard error of the x's times the square root of n minus 1. And then these are just substitution formulas. Guess what? You aren't going to have to calculate it by hand. You are not going to be calculating this by hand. But you need to recognize the formulas, because these are similar. These are formulas on your formula page. So here's what you do. To do your linear regression t-test, you enter the lists in your lists. The frequency is going to be 1, and you enter your alternative and you leave the regression equation blank. So note, they only test for beta equals 0, so if you're testing for something else, you need to calculate t by hand. So if they want you to test to see if the slope is equal to 6, you'll have to calculate this up here by hand. So on the TI-83S, the S is S sub B, not S sub B. So these are little things you have to pay attention to. So let's do this for this test. We want to know what is the probability that our slope, our observed slope, is greater than 0.0567. That's what we want. That's what we're doing. That's the probability that beta is greater than 0.0657. Well, that's the probability that t is greater than b minus beta over s sub b. That's as far as I have to go. Because the next thing I'm going to write down is whatever my calculator gives me is the t. Okay? I'm going to write down whatever my calculator gives me is the t. So we're going to go to stat, tests, and we want to look for our test. What test are we going to use? Linear regression t-test is what we're looking for. There it is. So we're going to do a linear regression t-test. See, the one below it is a linear regression t-interval. So we're going to do a linear regression t-test, and mine happened to be in list 2 and list 3. Frequency is 1. I'm doing greater than 0, and I don't put anything for the regression equation and hit calculate. So it tells me what's my t? 0.88. Okay, 0.884. I'm going to put that. And what's my p-value that it gives me? 0.196. So my p-value, this is a probability. The probability of this happening is 0.196. And what's my degrees of freedom? 13, because I had 15 observations minus 2. And so if I compared that to any level of alpha, what would I say? It's greater than any level of alpha. So I am going to reject the null and conclude that, no, fail to reject the null, thank you. I'm going to fail to reject the null, so I fail to reject the null. And what am I actually concluding then? No association between milk and mucus. Now, this down here should look familiar. Does this stuff down at the bottom look familiar at all? Okay, it is computer output, and the AP exam isn't. You're not going to have to do any of this stuff. You're not going to have to do any of this stuff for linear regression on your calculator actually, because they're going to give you this, and this actually gives you everything you need. This right here, 0.64 is
A.
That's A, or B 0. And then the 0.05667 is your B, or B1. The standard deviation of the slope, SE coefficient, this is standard error. The standard error, this is the standard error of the y-intercept. You don't need that. This would be S sub B right there. That's S sub B.